welcome to Helpful Hints for Chapter 3's lab. Here at Valencia's West Campus, we enjoy our small body of water, Lake Pamela, but it wasn't always so beautiful. Several years ago, we interrupted the ecosystem, and then Lake Pamela became rather ill. The health of the lake was measured by the Tropical State Index. When the Tropical State Index is high, then the lake is sick, so we want it to be lower. We're going to use our skills from Chapter 3 to make a linear model to express Valencia's efforts to restore Lake Pamela to health. So first things first, we're given a data set and a coordinate plane. So let's plot our data on the set of axes. You might notice that all the data points don't form a straight line, which is different from the collinear points that you're used to seeing in your algebra homework. Often data does not form a straight line, but we can still see where a linear approximation would fit the data well. Question 1 asks if the TSI is a function of years. This is often asked in algebra class, is y a function of x? How do you know? There are several different correct ways to answer this question, but they all hinge on the idea that for every one input should only map to one output. This is to say that for every x, you can only find one y that matches it. You could also describe this from the set of coordinates. Often we say that if the x values don't repeat, then you have a function. Another thing is that from the graph, you can see that it must be a function because it passes the vertical line test. But both of these explanations hinge on the idea that for every one input, you should get only one output. Number 2 asks us to find the line of best fit. Finding the line of best fit is a process from statistics. Notice how I'm redirected from finding the line of best fit to the process called linear regression in statistics. So what we're going to do instead is we're going to pick 2 points that best approximate the line as best as we can see, and then we'll use things from our algebra toolkit to find the line that goes through those 2 points, and therefore we'll have our line of best fit as best as we can guess with our algebra skill set. While there's not a single pair of points that gives us exactly the right answer, some choices are better than others. For example, I don't want to pick the first 2 points because they don't very well represent the line. I might not want to pick the second and third point either because they also don't represent the line very well. But we want to get as close as we can to finding a pair of points that will best represent this line. You might want to pick the coordinates where x is 0 and x is 10. Or maybe where x is 2 and x is 8. Because quite frankly, there are several good choices. Since we're estimating, then as long as we have something reasonable, it's okay. So copy down the 2 coordinates that you want to choose here. Draw a line through the 2 points you chose, all the way through the quadrant. Don't forget the y-intercepts, and all the way to the right side where x is equal to 12. Number 3 asks you to find the slope between the 2 points that you chose for number 2. Remember your slope formula. And after you use the slope formula and rounded it to the nearest hundredth, so by the way, let's point out that they're looking for a decimal, not a fraction, because we're talking about application. But after you have used your slope formula, then you're asked, does the TSI of Lake Pamela is decreasing over this time period. Does your slope reflect this? This is a question about the sign of your slope. Is your sign showing that it's decreasing over time? Number 4 asks you to find a linear equation that passes through the 2 points. Now you've already found your slope, so now we really need an intercept. One thing you might do to find your intercept is use your slope that you just found and the point slope formula that you might have seen in your ebook. However, if one of the 2 points that you chose was the coordinate where x is equal to 0, you already know what your b is, because your b is your y-intercept. The y-intercept is the y value when x is equal to 0. For number 5, you're going to use the linear model that you just found in number 4. You should have a function in this format. Now evaluate the function when x equals 11. Notice that you need to write your answer as a sentence, including what year that is. So, your sentence should say something like, in the year, and then 11 years after the start date, that's the year that you're going to use, so everyone will have the same year there. In the year, you get to fill in that blank. The TSI was approximately, and then you put the answer that you calculated. Number 6 asks you to plot that coordinate on your original graph. So go back to your original graph, find where x is 11, it's not marked, so you're going to mark it between 10 and 12, and follow it up to the line. Now, the point that you plotted, is it on the line? It should be, because that point was calculated from the same model that gave you that line. Number 7 asks you to use that model again. But instead of providing an x value, they've now provided a y value. We often see students try to evaluate the function this way, but this is not what we're looking for, because that implies that 35 is an x value. X refers to a year, y refers to the TSI, and you are provided a TSI. So replace all of f of x with a 35 and solve for x. Note that your instructions say to round your answer to the nearest year, but watch out on your quiz, because the instructions on the quiz are different. They say round down. So not to the nearest on the quiz, just always down. Last but not least, you are provided with a graph of the linear equations that all of us here at Valencia West found using linear regression from statistics. Here's the equation. It has a slope and an intercept. Here's a screenshot from a TI-84 where I ran the LinReg. Now this is not my data, and I am not the one who provided this formula, this equation, this mathematical model. However, I did want to show you that that is the same LinReg that we would come up with if we use the TI-84. Now you need to compare and contrast their slope with your slope. You need to compare their y-intercept with your y-intercept. By the way, while we're at it, notice the y-intercept matches where the line touches the graph. Does your y-intercept match where your line touches the graph? Use words to describe how close your slope was to theirs and how close your intercept was to theirs. You can say that they were very close or reasonably close. You can say that they were far away and discuss the algebra calculation error that made that happen. Thank you very much.